This instructional video is going over the exponent rules from the CFA that we've already taken. For this video, you need to copy down each problem as well as how we solve it so that way you can be prepared for when you retake the CFA. For our first problem, we're going to do 5 to the second power times 5 to the fourth power. We're going to start by breaking our problem down. 5 to the second power can be represented by 2 5s. 5 to the fourth power can be represented by 4 5s. Counting them up, we have a total of 6 5s. So our answer is 5 to the sixth power. To use the shortcut method, we take our original problem, and our shortcut when we're multiplying is to add the exponents. So we would add our two exponents, 2 plus 4, which would give us 6. The base number 5 stays the same, so that would be 5 to the sixth power. Either method gets you the same answer. For problem number 2, we're going to do the problem 8 to the fourth times 8 to the seventh. Just like the other problem, we're going to do both methods. You need to copy both so that way you can learn both. We start by breaking down 8 to the fourth power. So we have 1, 2, 3, 4 8s. And on the other side, we end up with 7 8s. Once you count them all up, we end up with 11 8s, 8 to the 11th power. To use our shortcut, we use our original problem. We're multiplying, so we add the exponents together. 4 plus 7 gives us 11. The base number 8 stays the same, and we end up with 8 to the 11th power in both methods. For number 3, we have x to the 10th power times x to the third power. Again, we're going to start by breaking our problem down. The first one, x to the 10th power, can be broken down into 10 x's. The other piece, x to the third, can be broken down into 3 x's. And when you count them up, we end up with 13 x's, x to the 13th power. If we wanted to use the shortcut method, x to the 10th times x to the third, we could add our two exponents together. 10 plus 3 is 13. The base number x would stay the same, and the 13 would be our new exponent. For problem number 4, we're going to do m to the 7th power times m to the 7th power. We start by breaking it down and writing out m 7 times. We do the same thing for the other piece. It is also m to the 7th, so it's going to be m 7 times. We total them all up, which is going to give us 14. Our base number m stays the same, and our new exponent becomes 14. If we want to use the shortcut, we would take our original problem. We would add the two exponents together, 7 plus 7, which would equal 14. The base number m stays the same, and 14 is our new exponent. For problem number 5, we're going to do 10 to the 2nd power times 10 to the 8th power. We start by breaking it down into 10 times 10. And on the other side, we're going to do 10 8 times. We total them all up, which gives us a total of 10. Our base number 10 stays the same, and our new exponent is 10. If we wanted to use the shortcut, we would take our original problem. We are multiplying, so we would add the two exponents together. 2 plus 8 which is 10. The base number 10 stays the same, and then we have our new exponent 10. For number 6, we're going to do 15 to the 6th power times 15 to the 11th power. We break down 15 to the 6th by writing 15 out 6 times. On the other side, we're going to write out 15 11 times. We total them all up, and we should have a total of 17 15 numbers. Our base number 15 stays the same, and our new exponent becomes 17. If we wanted to do the shortcut, we would have 15 to the 6th power times 15 to the 11th. We're multiplying, so we add 6 plus 11, which would give us 17. Our base number 15 stays the same, with 17 being the new exponent. Now let's take it up a notch and do some with the coefficient. 2x to the 4th times 5x to the 3rd. We're still going to break it down, and I'm going to show you the shortcut. For our breakdown, the 2 stays out in front, and we have x to the 4th, so we write that out 4 times. For 5x to the 3rd, the 5 stays out in front, and we write it out 3 times. We total up all of our x's, which is going to give us 7. So we have x to the 7th power. And then we multiply the coefficients. They are not exponents. They don't get added. They're just regular numbers. 2 times 5 gives us 10. 10 x to the 7th. If we wanted to use the shortcut, we're multiplying, so we would add the exponents, 4 and 3, which would give us 7. That leaves us with x to the 7th. We would then multiply the coefficients 2 times 5 to get 10. For number 8, we're going to do 3x to the 5th times 7x to the 4th. We start by breaking down the first section. The 3 stays out in front, and we break down x 5 times. For the other side, the 7 stays out in front, and we break down x 4 times. We total up our x's, which gives us a total of 9, x to the 9th power. And we multiply the coefficients, the regular numbers. 3 times 7 gives us 21. If we wanted to use the shortcut, we would take our original problem and we would add our exponents. 5 plus 4 gives us 9, which is where the x to the 9th comes from. We multiply the coefficients, the numbers out in front. 3 times 7, which is 21. For the next problem, we have 6x to the 7th times 9x to the 8th. We break it down by writing the 6 out in front, and then we have x to the 7th broken down 7 times. On the other section, we keep the 9 out in front, and we break down x to the 8th, and we write it out 8 times. We total up our x's, which gives us a total of 15. So that's x to the 15th power. We take the large numbers, 6 and 9, and we multiply them together to get 54. And so our answer is 54x to the 15th. If we wanted to use the shortcut, we would take our original problem, we would add the exponents together. 7 plus 8 is 15. The base number x has to stay the same, so that's x to the 15th. And then we multiply the coefficients. 6 times 9 gives us 54. For our last multiplication problem, we are going to do 11x to the 6th times 4x to the 7th. We break it down into 11 out in front, and x to the 6th we write out 6 times. On the other side, we keep the coefficient 4 out in front, and we break down x to the 7th by writing it out 7 times. We total up our x's, which is going to give us 13. The base number x stays the same, and our new exponent is 13. We take our coefficients, the large numbers out in front, and we multiply. 11 times 4 is 44. To use the shortcut method, we use the original problem. We're multiplying, so we would add the exponents. 6 plus 7 is 13. The base number x stays the same, with 13 being our new exponent. We multiply the coefficients, the large numbers out in front. 11 times 4 is 44. Now, we're going to move into some division problems, and we're going to use the same methods. I'm going to show you how to model it out, and I'm also going to show you the shortcut. Make sure you're copying down both methods so that you can learn it completely. Our first problem is going to be 11 to the 6th power divided by 11 to the 4th power. When we model it out, we keep the 11 to the 6th power broken down. We keep that on top. The 11 to the 4th power that we break down stays on the bottom. Once we have them written out, we can pair them up, top and bottom, and cancel them out. We are left over with 2 11s. Our base number 11 stays the same, and 2 becomes our new exponent. Now, to use the shortcut method, we're looking back at the original problem, 11 to the 6th divided by 11 to the 4th. We are dividing, so our shortcut tells us to subtract our exponents. 6 minus 4 is 2. The base number 11 stays the same, and 2 is our new exponent. For our second division problem, we're going to do the problem 4 to the 9th divided by 4 to the 5th. We break it down on top by writing it out 9 times. Across the bottom, we break it down by writing out the base number 4 5 times. We pair them up, top and bottom, and cancel them out. When we write our answer, the base number 4 stays the same. We have 4 remaining, and so that becomes our new exponent. To use the shortcut method, we have our 4 to the 9th divided by our 4 to the 5th. In division problems, we subtract the exponents. 9 minus 5 gives us 4. Our base number 4 stays the same, and our new exponent is 4. For our third division problem, we're going to do x to the 12th divided by x to the 4th. We start by breaking x to the 12th down. Rewrite out the base x 12 times. Across the bottom, we break it down by writing x to the 4th 4 times. We pair them up and cancel them out. And see how many do we have remaining. The base number x stays the same, and we have 8 remaining. X to the 8th power is our final answer. If we wanted to use the shortcut, x to the 12th divided by x to the 4th, we would take our exponents and subtract. 12 minus 4 gives us 8. The base number x stays the same, and 8 is our new exponent. For our fourth division problem, we're going to do m to the 10th power divided by m to the 9th power. We start by breaking down m to the 10th by writing out our base m 10 times. Across the bottom, we break down m to the 9th by writing out the base m 9 times. We pair them up, top and bottom, and cancel them out. And see how many we have left over. Our base number m stays the same, and our exponent is simply 1. If we wanted to use the shortcut method, we would take our original problem, m to the 10th divided by m to the 9th. In division problems, we subtract the exponents. 10 minus 9 is 1. The base number m stays the same, and our exponent is a 1. For our 5th division problem, we're going to do 8 to the 11th power divided by 8 to the 7th power. We start by writing out 8 to the 11th, 11 times. Across the bottom, we write out 8 to the 7th, 7 times. We pair them up, top and bottom, and cancel them out. And to see how many is left over, our base number 8 stays the same, and we have 4 left over, which becomes our new exponent. If we wanted to use the shortcut, we take our exponents and we subtract. 11 minus 7 would give us 4. 8, our base number, stays the same, with 4 being the new exponent. For number 6, we're going to use the problem 10 to the 9th power divided by 10 to the 3rd power. We start by breaking down 10 to the 9th by writing out 10 9 times. Across the bottom, we write out 10 3 times to represent 10 to the 3rd. We pair them up and cancel them out and see how many are left over. Our base number 10 stays the same, and we have 6 remaining. So 6 becomes the new exponent, 10 to the 6th power. If we wanted to use the shortcut, we would take our original exponents, 9 and 3, and subtract them, because in all division problems, we subtract the exponents. 9 minus 3 gives us 6. The base number 10 stays the same, and 6 becomes our new exponent. For our 7th division problem, we're going to take it up a little bit and do the problem 12 x to the 5th divided by 3x to the 3rd. We're going to start by modeling it out. The coefficient 12 stays out in front, and x to the 5th can be broken down by writing x 5 times. On the bottom section, the coefficient 3 stays out in front, and x to the 3rd can be broken down by writing x 3 times. We pair up and cancel out the top and bottom x's that match. We have 2 left over, so our base number x stays the same, and our exponent is now a 2. The coefficients 12 and 3 are just standard numbers, and so we can divide 12 divided by 3 to get 4x squared. If we were to use the shortcut, we could take our original problem, and since we are dividing, we would subtract our exponents. 5 minus 3 is 2, and so our base number x stays the same with our new exponent 2. The coefficients out in front are regular numbers, so they are divided. 12 divided by 3 is 4. Either method gives us the same answer, 4x squared. For our 8th division problem, we're going to do 20x to the 9th divided by 5x to the 7th. To model it out, the coefficient 20 stays out front. we can break down x to the 9th by writing out the base number x 9 times. Across the bottom, the coefficient 5 stays out in front, and we break down x to the 7th by writing the base number x 7 times. We pair them up and cancel them out, one on top of the other, to see how many we have left. The base number x stays the same. We have 2 x's remaining, so that's our new exponent. And our coefficients we divide. 20 divided by 5 gives us 4, 4x squared. If we wanted to use the shortcut, we would use the original problem. Because it is a division problem, our shortcut is to subtract our exponents. 9 minus 7 gives us 2. The base number x stays the same. 2 is our exponent. And we divide our coefficients. 20 divided by 5 gives us 4, 4x squared. For our 9th division problem, we're going to do 44x to the 12th divided by 11x to the 4th. We start by writing it out. The coefficient 44 stays out in front. X to the 12th can be broken down by writing the base number x 12 times. On the bottom, the coefficient 11 stays out in front, and we write our x to the 4th 4 times. We pair them up and cancel them out, one on top of the other, seeing how many we have left. The base number x stays the same. We have 8 x's remaining, which is our new exponent, and our coefficients we divide. 44 divided by 11 is 4, 4x to the 8th. If we wanted to use the shortcut, we would take our original problem. Because it's a division problem, we subtract the exponents. 12 minus 4 is 8, which is how we get our new exponent, x to the 8th power. And we divide the coefficients. 44 divided by 11 is 4. For our last division problem, we're going to do the problem 32x to the 7th divided by 4x squared. We start by writing it out. 32 stays out in front, and x to the 7th we break down by writing x 7 times. Across the bottom, the coefficient 4 stays out in front, and we write x squared twice. Pair them up and cancel them out, and see how many are left over. We end up with 5 x's left over, so x to the 5th is our new exponent. Our coefficients are regular numbers, so we can divide 32 divided by 4 to get 8. If you wanted to use the shortcut method, you would take the 32x to the 7th and the 4x squared, which are being divided. Our shortcut when dividing is to subtract our exponents. 7 minus 2 is 5. The base number x stays the same. The 5 is the new exponent. And our coefficients are divided. 32 divided by 4 is 8. We're now going to move on to some problems that involve raising to a power. Our first problem is going to look like this. 3 to the 3rd power raised to the 4th power. Now in this method, I am not going to model out any of the problems. I'm only going to use the shortcut. When we have our exponents that are side by side like this, it means that we are going to multiply. So we would multiply the 3 and the 4 exponents together, which would give us 12. Our base number 3 stays the same, and 12 is our new exponent, which becomes our final answer, 3 to the 12th power. Our next problem is going to look like this. We have 4 to the 2nd power raised to the 5th power. Again, those exponents side by side is our key to multiply. So we can multiply the 2 times 5, which gives us 10. The base number 4 stays the same, and our new exponent is 10, 4 to the 10th power. For our third problem, we're going to do x to the 4th raised to the 6th power. Again, those exponents side by side, our key is to multiply. We multiply the 4 times the 6, which gives us 24. Our base number x stays the same, and our new exponent is 24. For problem number 4, we have m to the 6th power raised to the 7th power. Our key is that our exponents are side by side. When we're raising to a power and those exponents are side by side, we multiply them together. 6 times 7 gives us 42. The base number m stays the same, and our new exponent is our 42. For number 5, we have the problem 8 to the 10th power raised to the 3rd power. When raising to a power, we multiply those exponents that are side by side. 10 times 3 would give us 30. The base number 8 stays the same, and our exponent is now 30. For problem number 6, we have 5 to the 11th power raised to the 2nd power. Our shortcut is to multiply the exponents together. 11 times 2, which gives us 22. The base number 5 stays the same, and 22 is the new exponent. Now, let's take it up a notch. Our next problem is going to be 8x squared raised to the 3rd power. Just like before, we can go ahead and multiply those exponents that are side by side. 2 times 3 gives us 6. And so we end up with x to the 6th power. However, we also have the coefficient 8 out in front. We use the exponent to represent the 8 as well. So we still have our coefficient 8, but we take the outside exponent 3 and place it with the 8 in the problem. Our final answer is 8 to the 3rd power, because again, that is our outside exponent, and then x to the 6th power, because we multiplied the exponents that are side by side. For this one, we have 11x to the 4th raised to the 2nd power. Again, the exponents that are side by side can be multiplied. 4 times 2 is going to give us 8, so that would give us x to the 8th power. But we also take the outside exponent, which is a 2, and put it with the coefficient 11, 11 to the 2nd power. Sometimes your problems will be taken to the next level, in which case they actually want you to solve the coefficient. So for example, 11 squared is 11 times 11, which if you were to multiply that, 11 times 11 is 121. And then you have your x to the 8th power. So you need to be able to recognize both forms, as in problem number 7, where we left the exponent with the coefficient 8, and problem number 8 here, where we solved the coefficient 11 squared into 121. You need to be able to do both and recognize both for when you see it on either an assignment or an assessment. For the next problem, we're going to have 19x to the 5th raised to the 3rd power. We start by multiplying the exponents that are side by side. 5 times 3 is 15, meaning we have an answer of x to the 15th. However, we also take the outside exponent 3 and we put it with the coefficient 19. So that gives us 19 to the 3rd power. We are not going to solve this problem further because 19 to the 3rd power would give us a really large number that is too complicated to find without a calculator. So we're going to keep it as 19 to the 3rd, x to the 15th. For our last raising to a power problem, we're going to do 3x to the 7th raised to the 2nd power. We start by multiplying the exponents that are side by side. 7 times 2 is going to give us 14. So we have an answer of x to the 14th. We also take the outside exponent 2, we put it with the coefficient 3, so we get 3 to the 2nd power. This problem we can solve further because 3 squared is easily solvable, 3 times 3, to give us 9. 9x to the 14th power is going to be our final answer. Moving on from raising to a power, we're now going to move into problems dealing with 0 exponents. Anytime we have a 0 exponent, as in 19 to the 0 exponent, your answer is going to be a 1. That doesn't mean that the exponent is a 1, it means that the entire answer is 1. The same thing can be true about 125 to the 0 power. The answer is 1. The same thing can be said about a variable. X to the 0 power is 1. it doesn't matter the variable. If I used m to the 0 power, the answer is still 1. Again, the exponent is not a 1, the entire answer is a 1. It also works with negative numbers. Negative 9 to the 0 power is 1. It's not a negative 1, it's just 1. Same thing if I gave you 16 to the 0 power. Again, even though it's negative, the final answer is just 1. However, in order to take it up a notch, we would have problems that look like this. 119 minus 12 to the 0 power. We know that 12 to the 0 power is 1, but the 119 does not have an exponent, meaning it stays the same. So we actually have to solve the problem itself. 119 minus 1 is 118. A similar problem would be 132 times 15 to the 0 power. Again, anything to the 0 power is 1, but the number 132 doesn't have an exponent, so it stays the same. 132 times 1 is 132. Another problem we can do is 216 plus 37 to the 0 power. Anything to the 0 power is 1. The 216 does not have an exponent, so it stays the same. 216 plus 1 is 217. And the last problem we're going to do for 0 exponents is 11 times 4 to the 0 power. Anything to the 0 power is 1, but the 11 does not have an exponent. So 11 times 1 is 11. The final set of problems are going to be dealing with negative exponents. For our first problem, we have 15 to the negative 3rd power. When you have a negative exponent, you take the base number, in this case 15, and you write it in the denominator. The negative exponent changes to a positive exponent when we make it into a fraction. Anything that is in front of the base number and the exponent goes on top. If there is nothing in front of the base number and the exponent, we leave it as a 1 on the numerator, a 1 on top. Another example is 8 to the negative 4th power. Again, the base number 8 stays on the bottom. The negative 4 exponent changes to a positive 4 exponent. There is nothing in front of the base number 8, and so we leave it as a 1 on top. Our next example, x to the negative 7th. We take our base number x and put it in the denominator. The negative 7 changes to a positive 7 when we write it as a fraction. There is nothing left in front of the variable, in front of the base number, so we leave it as a 1 on top. Another example, using a variable, would be m to the negative 11th. We take the base number m and place it in the denominator. The negative 11 exponent changes to a positive 11 when we write it as a fraction. There is nothing in front of the base number m, so we put it with a 1 on top. Our next example, 6 to the negative 9th, can be solved in a similar fashion. The base number 6 goes in the denominator. The negative 9 exponent changes to a positive 9 exponent. There's nothing in front of the base number 6, so we leave it as a 1 on top. Another example would be 5 to the negative 10th power. The base number 5 goes in the denominator. The negative 10 exponent changes to a positive 10 when we write it as a fraction. There's nothing in front of the base number 5, so we leave it as a 1 on top. To take it up a notch, we can now do the problem 11x to the negative 4th. The base number x stays on the bottom. The negative 4 exponent changes to a positive 4 exponent. The 11 is out in front, so the 11 stays on top. In our next problem, 15x to the negative 6th, the base number x goes in the denominator. The negative 6 changes to a positive 6 when we write it as a fraction. The 15 is out in front, so the 15 stays on top. For our next problem, we're going to use variables. So ax to the negative 8th. We start by writing the base number x in the denominator. The negative 8 exponent changes to a positive 8. The a is out in front, so the a stays on top. Our last example is going to be mx to the negative 12th. The base number x goes in the denominator. The negative 12 exponent changes to a positive 12. The m is left out in front, so the m gets left on top.